And kinematics. Particle of mass 5.5 kg projected vertically upwards from horizontal ground speed 25 meters per second. Find the speed when it reaches a height of 20 meters above the ground. So the object is going upwards. We have initial velocity, we have distance upwards traveled, and we have the acceleration downwards. So the u, let's say positive, is upwards, so going upwards positive, going downwards negative, going upwards positive. We use this MF19 formula. We take the square root of both sides, plug in the numbers, use a calculator. We have the v. When A reaches a height of 20 meters, it collides with a particle B of mass 0.3, which is moving downwards with speed. So this is when A reaches a height of 20 meters. Previously, we know that at 20 meters, the speed of A is 15 previously. Okay, so A is moving upwards. This is the speed. It collides with B with this mass and this speed downwards. They collide and B is brought to rest. So after the collision, the B is at rest. The A, we need to find the velocity. We need to show that the velocity is 4.5. So we use conservation of momentum. So momentum before equals momentum after. So before we have, let's say going up is positive, m times v, momentum of A before the collision, m times v, this is negative because going downwards is negative, momentum of B before the collision, and after the collision the momentum here is 0. Of course, the momentum here is 0.5 times v. We use a calculator for this left hand side and divide by 0.5. We get what we need to prove. Okay, negative means going downwards. Now find the time interval between A and B reaching the ground. Okay, so for A, we know that after the collision here, it is going downwards with velocity 4.5 meters per second. This is the acceleration, also downwards, and it's going downwards 20 meters because the collision happens at 20 meters above the ground. So to fall back to the ground, it's traveling 20 meters downwards. So we use s equals ut plus 1 half at squared. The s is, so in this case, we say going down is positive. The s is positive, the u is positive because all going down. Okay, so we can simplify the quadratics, can factorize, and we have the time. So this is the time for A to reach the ground after the collision. And now for B, after the collision, the B is at rest, so the velocity is 0. So for this calculation here, we're going to use going down is positive again. The U is 0. The A is 10 positive, going down 20 positive. So we use the same formula. We have the T. Question is the time interval, so the difference in the time. So we subtract. The B falls later, the A falls first, and then we subtract here. We get the difference in the time, or the time interval in between A and B reaching the ground. Okay, so the final answer is 0.4 seconds. Okay, I'll